Hello students, welcome to RD Chemistry. In this video, I'll explain electron displacement in covalent bonds. You know that there are two types of bonds. What are two types of covalent bonds we have got? First one is the sigma bond and other one is the pi bond, right? The first type of electron displacement is the inductive effect. It is also written as the I effect. I stands for the inductive. Consider example of methyl chloride CH3Cl. Carbon is attached to the chlorine atom and in turn attached to the three hydrogen atom. Correct? Consider carbon chlorine sigma bond. The bond is now sigma bond. Here there are sigma electron. The electron present in the sigma bond is called as the sigma electron. Consider electronegativity of carbon and chlorine atom. Chlorine is more electronegative, gets partial negative charge, and carbon gets partial positive charge. And electron pair is very closer to the chlorine atom. So there is a displacement of the sigma electrons toward the more electronegative chlorine atom. So this kind of displacement on the sigma bond by the sigma electron is called as the inductive effect. Chlorine atom is withdrawing the electron toward itself. So this group is a minus I effect group. Okay, is a electron withdrawing group. CH3, which is donate electron, is called as the plus I effect group. Okay, so there are different types of minus I effect are given. See, these are the examples, so you have to remember this one. Similarly, for the plus I effect, like tertiary alkyl group, secondary, primary goes on in the priority list they are given. Clear? Right? The next one is the resonance effect or mesomeric effect, which is called the R effect or the M effect. Further, there are two types, plus R effect and minus R effect. Now, here the groups attached to the, for example, let me take OH group. Of OH group is attached to the conjugated system. What is conjugated system? Conjugated system means they should be alternate double bond or single bonds like this, or they should be carbon carbon double bond, then carbon carbon single bond, okay, then carbon carbon double bond. This is known as the conjugation, single bond double bond conjugation. Also we can attach a group which contains the lone pair of electron. Remember, lone pair of electron is in conjugation with the sigma bonds and the pi bonds. So what will happen in this case? Electron pairs can be given to the conjugated system. Is a given. Okay. So it is donating electron pair to the benzene. Here also conjugation involved. Okay. Lone pair becomes the bond, bond becomes the charge, and it goes on the process. Okay. So if the donates electron pair, it is called the plus R effect group. So OH, OR. Remember, oxygen contains lone pair, sulfur contains lone pair, nitrogen contains lone pair. On the other hand, if there is a benzene ring attached to the, let me take a aldehyde group, okay, C double bond OH, correct? Oxygen more electronegative. What will happen? Oxygen pull the pi electron toward itself. You know the pi bonds are weaker, correct? So in turn, it pulls the electrons from the benzene ring. So there is a delocalization. So there is a delocalization. Okay. So remember there is a delocalization of pi bonds and the lone pair of electron. When I say delocalize, I mean complete transfer of the electron from one atom to the another atom. Okay. So you have to remember the examples for the plus R effect group and the minus R effect group. These are electron donating groups and this side is electron withdrawing groups, minus. Clear? Next one, the electromeric effect. It is also called as the E effect. Again, there are two types, plus effect and minus effect. Now, what is electromeric effect? See here, transfer of electrons to the pi bond. Okay, so that means the pi bonds are migrating. Okay, it can be toward the attacking reagent or away from the attacking reagent. Now see this example, carbon carbon double bond is of the alkene. So there is a reagent, electrophiles are positively charged. Whenever there are double bonds is electron rich and H plus electropositive, electron deficient. So pi electrons are moving toward the attacking reagent. As a result, the pi bond breaks and one of the carbon atom gets the positive charge. That means pi electrons are moving toward that H plus atom. Okay, so it is toward the attacking reagent and positive charge is created and it is called the plus effect. Okay, electrons are donated. And minus effect means, okay, here there's a nucleophile like Cn minus. It attacks the electropositive carbon. Compare electronegativity of carbon and oxygen. Carbon electropositive, oxygen electronegative. Therefore, negative charge species generally attack the electropositive center and pi bond moves because you have to make altogether how many bonds? 4 bonds with the carbon atom. So here pi bonds are going away from the Cn minus or it is moving toward the electronegative element. Okay, so it moves to the electronegative element like oxygen, nitrogen, sulfur when they are joined by the multiple bonds. Okay, and remember this is taking place only in the presence of the reagent, attacking reagent. Suppose there is no attacking reagent, if it is removed, then you will get back the original molecule. Next one, the hyperconjugation. In the hyperconjugation, alkyl groups generally attach to the carbon-carbon double bond or unsaturated groups. Unsaturated groups like this. Now here the carbon attached to the hydrogen 1, 2 and 3. Okay, then carbon, hydrogen, then there is a double bond carbon, hydrogen, hydrogen. In this case, what will happen? Carbon hydrogen sigma bond is there. Sigma electrons are moving towards, okay, the carbon carbon double bond. That means the sigma bond breaks, completely breaks, okay, and this double bond breaks, pi bond breaks easily and form the negative charge. So we'll get a structure like this. So carbon, hydrogen, hydrogen, and H is lost at the H plus ion. Then we'll have the double bond here, carbon, hydrogen, single bond, hydrogen, hydrogen, negative charge. So interaction of the sigma bond, sigma electron with the pi electron in the unsaturated molecule is called the conjugation effect. Now bond is broken here, right? Sigma bond. Therefore, this effect is also called the no bond resonance. It is also known as the no bond resonance. Okay, no bond resonance it is. Or also you can take example of the benzene ring attached the benzene ring attached to the CH3. Okay, CH3 like this. You know that in the case of benzene, there is alternate double bond and single bonds are there. Attach the carbon, hydrogen, hydrogen, hydrogen. Correct? Now sigma bond can be broken. Okay, so it forms the new bond and sigma pi bond migrates like this. And this H is lost as the H plus ion. So there is a resonance in the benzene ring, but there is a carbon hydrogen bond is lost. It is called the no bond resonance. Okay, clear? In this case, carbon-carbon double bond should be attached to carbon, should contain hydrogen atoms. Okay, here also here, the carbon-carbon double bond of the benzene attached to carbon containing hydrogen. That means we should have the carbon containing hydrogen like this, or it can be CH2, other group in the form of CH3, or it can be like a CH, then a CH3 twice, or carbon attached to CH3 thrice. Okay, tertiary, secondary, primary, and simply methyl group. Okay, so the order of effect for hyperconjugation, the methyl is more, then primary, secondary, and tertiary goes on like this. Okay. Question number 1. Inductive effect involved. Remember, inductive effect refers to the carbon, okay, some other group, and there is a sigma bond. Sigma electrons are migrated to a more electronegative element. So answer is the first one. So these are a straightforward question. Sigma electrons are displaced. Question number 2. Plus I effect is shown by. For plus I effect is an electron donating group. CH3 is electron donating group. Bromide, bromine, chlorine and nitro groups are, these three are electron withdrawing groups. So the answer is option number 1. Question number 3. Mesomeric effect involves delocalization of. Mesomeric effect is also called as the R effect. Okay, resonance effect. They should be lone pair electron in conjugation with the alternate double bond and single bonds. Correct? which means double bonds can be migrated. Pi bonds are easy to break, it will migrate. Or pi lone pair electrons can also be migrated like this. Okay, so protons will not move, sigma electrons will not move. Okay, so answer is pi electrons here. Clear? Question number 4. Which of the following species does not exert a resonance effect? Let us take first example. It is phenol. Benzene ring attached to the OH. Okay, great. Oxygen contains lone pair. It is involved in the resonance. Possible. Resonance is possible. Next one. Chlorobenzene structure. Chlorine contains 3 lone pair of electrons. Correct. One of the lone pair is delocalized on the benzene ring. Next one is the benzenamine or aniline containing nitrogen. Nitrogen contains lone pair, is involved in the resonance. Correct. Next one, benzene ring is attached to the nitrogen, hydrogen, hydrogen, hydrogen. Now compare with this molecule. Lone pair is lost from the nitrogen positive charge. Whenever positive charge is a nitrogen, it acts as the electron withdrawing group. So lone pair is not delocalized. Therefore, answer is option number 4. Right? Question number 5. In electrophilic aromatic substitution, nitro group is a meta-directing because, let me write down the resonance structures. We have got benzene ring attached to nitro group, N double bond, single bond oxygen. Oxygen more electronegative, so low pi bond has migrated like this. Here bond migrates like this. Okay, so pi bond migrates, so we'll be getting structure like this. Okay, these are two double bond as such. Here get a positive charge, then double bond N oxygen, single bond oxygen minus. Now what will happen? This pi bond migrates now. Resonance is seen. Okay, so we'll get now next structure. So we have got now this pi bond as such. This pi bond will migrate here, positive charge here, then double bond here, N oxygen minus and oxygen. Again, pi bond migrates like this. So we'll get one more structure, correct? So we'll get a double bond here, plus sign, then double bond here, double bond N, O minus and oxygen here, correct? Can you see here? Positive charge is there on the ortho and para positions only, correct? Ortho and para positions only. They mentioned it is a electrophilic. What do you mean electrophiles? Electrophiles are positively charged. Electrophile cannot attack the ortho position. Positive cannot attack the positive position. Which means that there are meta positions here. This is the meta position, correct? This is the meta position. This is the meta position. This is the meta position. This is a meta position. This is also a meta position. Which means on meta position there is no positive charge. Positive charge exists only on the ortho and para. Which means there is more electron density on the meta position. Therefore, electrophile easily attack the meta position. Okay. So what is the answer now? So on ortho and para position there is no electron density. Electron density decreases. Okay. Clear? But we are not increasing the electron density on the meta position. There is no negative charge in meta position. So you have to appropriately select the answer. Okay. See the options. Okay. Answer is D. Decreases electron density on ortho and para positions. Clear? So answer is the fourth one. Question number 6. Mesomeric effect or R effect involves either we should have the lone pairs, pair of electron conjugated with the double bond, single bond, or they should be pi electrons, correct? So the appropriate answer is delocalization of the pi electron. Question number 7. Resonance effect is not observed in. Okay. For resonance effect, there should be lone pair and there is a conjugation of the carbon-carbon double bond and the single bond, correct? Now see here, first example. Chlorine contain lone pair. Lone pair can be donated like this. So there is a resonance effect. Conjugation is there. See the next one. That is a nitrogen contains a lone pair. Okay, there is a sigma bond here, but double bond is not here. That means it cannot interact with the pi bonds. This should be the answer. Second one is the answer. We'll go for third and fourth option also. Here, double bond, single bond, double bond. So it can migrate it like this. Okay. This carbon will get the negative charge, possible. And this carbon will get the positive charge, possible. Okay. Next one. Here, nitrogen more electronegative. It can pull the electron toward itself. Okay. So what will happen now? This pi bond migrates here. and one of the pi bond from here migrates on the nitrogen, and nitrogen will be negatively charged and this carbon will be positively charged. So there is a delocalization of the either pi electrons only or sigma or lone pairs on the pi bonds. Okay, so the answer is option number 2. These lone pairs are not in conjugation with the pi electrons. Clear? Like the videos, share the videos, and please do subscribe RD Chemistry, and thank you for watching.